Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning to you all. Right. Currently, nearly 1 minute more for the seminar to start. So my name is Sharaf. So I will be your chemistry mentor. Right. So this is going to be a free seminar for the organic chemistry session. So this can be a very useful area and a very easy place to gain marks. So it is a very crucial part for you all to do organic chemistry since it comes on MCQs, structure, and essay mostly, right? And it is the easiest part to score more marks within the less time if you are a pro in it. So the more you work, the more easy it becomes once you are in organic chemistry. So it is such an easy part, right? I just needed to do this seminar because you guys should know how far is this organic chemistry going. Most of us don't know the value of organic chemistry, right? Because some of you are doing maths, and since maths people think chemistry in certain areas you feel difficulty in by hearting. Some of you, not all of you, there is a chance for you during the seminar to build your mind to do the organic chemistry, right? So before going into this, we will first know what is organic chemistry, right? So organic chemistry in a perspective under your point of view is actually the compounds which contain carbon, right? Which contains carbon. Accordingly, once you start about the organic chemistry, right? So we can divide them according to two types, right? So in organic chemistry, right? In organic chemistry, you should know we have the compounds, right? So the compounds in it can be divided into two types. One is aliphatic, and the other one is the aromatic, aliphatic and aromatic. In the aliphatic cases, you have to keep in mind, in aliphatic, the carbon chain will be as linear as possible, right? Will be as linear as possible. In the case of aromatic, there will be ring structure. So according to our syllabus, we have so many ring structures. So I'll give a simple example like benzene, right? So the meaning of aromatic means these compounds, these ring structured compounds, they all have certain smell. That is why the name aromatic compound came. In the aliphatic, in a sense, we have everything in a sequence. So they are in a straight chain, and it can be a very large compound too. Like for example, in our day-to-day lives, we used petrol 92, right? In other words, you can say octane 92, which is 16 carbon. So there are lots of things that you can know according to aliphatic organic compounds and aromatic organic compounds. Today, I will be doing the organic chemistry by splitting the areas into two types. In the resource book, they have mixed up everything. I'm going to separately do it like this, right? So I will be splitting you all the straight chain compounds in this group and the aromatic part in this group. So it will be easy for you to memorize at the sense, also understand what is happening in it, right? So before going into this, you need to know what is there in this unit. So in that case, what we will do is, we will see what is there in this perspective. So according to your point of view, first and foremost, in organic compounds, you will be learning what is the IUPAC of the organic compounds. So there are certain rules, right? There is going to be certain rules. Secondly, you will be discussing about the isomers or isomerism, right? You will be studying about the isomerism. Right? It's a very interesting and a detailed part, but I'll be doing the isomers firstly with the MCQs that I have given in the tube. So in the tube, right, I have provided a tube. There you have all the sets of questions. Most probably you have all the sets of question in it. So I have provided a tube for you all, right? So it contains around 33 pages and all, and most of them are model questions and term paper questions, right? So I have given you on which all areas it has come. So I'll be doing you the MCQs, and after that I'll go with the structured essay part, because you need to know what are the reactions that is taking place within the functional groups, and then you need to know what is happening in the isomers and how to identify them. So I'll do the structures later. We'll do some MCQs after discussing this part. Same way over here. And second thing, and the thirdly, you need to know, we are going to do a area, right? We are going to deal the areas with the functional group. So you can say, in short, you can say the reactions based on them, right? And then you will see how we can prepare them. You can see how we can prepare them. So if you know the preparation way of the functional groups, for example, it can be carboxylic acid, everything. So I'll be explaining in detail. Don't be in a hurry, right? I'll be explaining in detail in a sequence manner, so you can understand what is happening in the other parts, right? So in preparation method, right? If you know the preparation method, reaction method, then there's an area in the essay part as well as in the structured essay part, which is called the reaction mechanism, right? So completely you can say them as reaction mechanism, right? So in the reaction mechanism area, you can have this, right? So in the reaction mechanism, in a sense, they'll be using full arrows, sometimes half arrows. What do you mean by this? So I will explain you what is happening over here, right? There's a deeper part in this. If you know this, you can do conversions also. The reason I put reaction mechanism over here is because the products or the preparation method, if you know the preparation method of a functional group, you need to know how is the reaction mechanism taking place, right? So I will take this area as the last part of the organic chemistry. I'll take this as the end of the topic, right? At the last end of the topic of the organic chemistry. So today this seminars will end with the reaction mechanism, a very easy part. So if you know this, you can do the conversions, right? And then you have the acidity, right? Acidity, basicity, right? Basicity in this whole area of certain compounds. Like in acidity basis, you will be comparing about the terminal hydrogen alkynes, right? With the alkynes. Then you have the alcohols. Then you have phenol. Then you have carboxylic acids, right? So this will be there under the acidity basis. In the case of basicity, let me write in the other way. In the case of basicity, you have amides, you have amines, right? Then you have aniline, right? Aniline. And these are the people that you need to know. right? You need to know what is happening over here. And among this part, within this part only, we have another area. So I have taken out that area. So we'll be studying stabilities also as a separate part, right? You should know why these products are being stable to this, right? As a stability, right? So accordingly, all these areas will be covered inshallah by today. Today we will cover this all. So no harm those who are just started organic chemistry, or those who don't know organic chemistry can also join this seminar, right? No harm. Please share this link to your friends, because this is a very important part, and those who are able to get this seminar by today, you can be able to do certain MCQs, right? Some structures and some essay parts. So very easy one, right? I will be explaining you in detail what is happening over here, right? If you can understand this, inshallah you can score full marks in the organic chemistry area, right? For that you need at most idea about what is there regarding this area. Next thing, you need to know what is the main case in the cases of each of these subunits. Within the first 10 MCQs will get a IUPAC, right? Isomers, it can come either on the 30th, between 31st to 40th MCQ, or it can come from 41st to 50th MCQ. They can ask relevant questions. So I have given you in the model tube, right? The model paper tube. Usually reaction mechanism, reactions will be there a lot in this area, right? In this area. Then acidity, basicity, they'll ask you the comparison, most probably in the MCQ parts. Regarding the stability, also you have certain MCQs. It has come in the Moratoa paper, FWC paper, Royal College, Ananda College. So there are lots of papers in 6th term and all. They have asked regarding the stability and the acidity, basicity separately. So they haven't separated these areas in the resource book. So we will do it in a summary, right? We have summarized them each. So it will be easy for you to cover, right? So now we will be discussing with the IUPAC. We will be discussing with the IUPAC. So IUPAC means it is the naming of the compound. You're going to name the compounds. What kind of a compound? In this case, you have in your syllabus you have IUPAC in inorganic chemistry, in the chemical calculation area also. Now you have in the organic chemistry, right? So in inorganic chemistry you have in the complex compounds. So naming of the complex compound. In the case of chemical calculation, naming of the simple compounds. For example, like potassium chloride, sodium chloride. So in those cases, you will know the IUPAC. But now today we will be discussing about the organic chemistry. In the organic chemistry, right? In the organic chemistry, this plays a very important part, right? So this plays a very important part. So today I will explain you this one using certain MCQs, right? So before that, before going into the IUPAC, let me give certain terms, certain short terms that you need to know. Maybe you guys can, maybe you people, students can know. So first thing, for numbering the carbon chains, there are certain terms, right? There are certain terms. So one is, so if the carbon containing compound has one carbon, you will say this one as meth. If it is 2, then you use eth. If it is 3, you will use prop. If it is 4, you will use but. If you use 5, it is pent. If it is 6, you will say hex. If it is 7, you will use hept. Here only you have the change, not sept, it is hept, right? So this is the numbering of the carbon chain. If the carbon number of carbons that you have in a compound is actually 1, then you will use meth. If it is 2, you will use eth. 3 means prop, 4 means but, 5 means pent, 6 means hex, 7 is hept, respectively. So I have given you until 7 because they have asked maximum until 7, not more than that, right? And let's see an example. Now let's see an example. So let's say now you're going to have an alkane, right? Now let's consider about the alkane. So what do you mean by alkane? Alkane means the compounds that contain carbon-carbon single bond, right? Within their carbon atoms, they have only single bond. So over here, let's see this example. Right. So by explaining, throughout this explanation, keep in mind, I will give you, throughout the explanation, I will give, you have to get the lecture notes, right? So today it is going to be a long-term seminar, so I won't be giving you the notes. So get the notes, what you understood from this part, right? So if it is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, right? Now here, see here, now this is your example. Now we have this set of carbon. So now you have a problem. How can we name this? So first things first, as I said, you should know the numbering of carbon chains. Once you start numbering, you should keep in mind the one who receives the less number by numbering in either directions. It can be from left to right or right to left, right? From up to down or down to up. Doesn't matter. There you should know the main functional group has to be in small number, right? It has to be the number less in the direction that we took. So in this case, I can number this one as 1, 2, 3, 4, 5, right? Or I can use this 1, 2, 3, 4 and 5. Possible now? You can go like this or you can go like this, right? Or you can use this 1, 2, 3, right? So you can use this way also, right? Let me round this up so you won't get confused, right? So I can use in this direction, I can use in this direction, or I can use in this direction, or I can use in this direction, and I can use in the opposite way also. I can mark it like this 1, 2, 3, 4, and then you have 5. You can use 1 over here, 2, 3, 4, and then you have 5, right? Here you have 1, 2, 3. So nearly you have 6 ways to number the carbons that you got, right? Now see here, in any of this direction, you should your first rule is you have to find out the longest carbon chain. Okay? First and foremost, before going on to the carbon chain, keep in mind, you should know what kind of a group is this. So accordingly, as I said, this is actually an alkane, right? Right? So keep in mind, this is the actual case here, right? So this is the alkane over here. In this alkane group, right, you need to know that certain people cannot be considered as functional group. Here you can't say alkane is a functional group, right? There are certain cases here. So in this alkane, I have marked the numbers here, right? Already I have marked the numbers here. Now see, I'll be using either one of this direction. And in this case, I will be using the rule that I have to select the longest carbon chain. But there's a problem. If I use either one of these way, there is going to be certainly another party where you cannot consider. For example, if I consider these people over here, then here I have another separate guy. So what I will do for this? So you will have some problem. What should we do if these kind of people come? So accordingly, the people who are excluded from the carbon skeleton that we selected will be actually called the substitutes, right? Will be called as a substitute, just like the football or cricket match. If someone gets injured, and you will put a person, so it's called a substitute. Same way here. So here you have a substitute. If you go in this direction, you will have a substitute over here, right? But what is our rule? We need the longest carbon chain. So in this case, I can use either this way or this way, right? Or I can use this way or this way. I can't use 1 or 3. Understood? So what I can do is I can directly omit this pathway, right? Now I have either of these 3 ways. Now see. So if I go in this direction, I have 1, 2, 3, 4, 5. If I go in this direction, 1, 2, 3, 4, 5. Right? So in this direction, I have 1, 2, 3, 4, 5. But in this case, I have 1, 2, 3, 4, 5. Same way over here. 1, 2, 3, 4, 5. Okay. Our next rule is you should get the substituent or whatever person that you have as the smallest number. Then it has to be as small as possible, not 0. It has to be as small as possible. It can be 1 and between the range of numbers that you have. So between that range, which number is less to this group has to be selected. So in this case, see here, I have used this way. So if I use in this way, I will get this guy as the longest number. So this is actually 4, right? So because 1, 2, 3, 4, 5. So if I select this carbon chain in this way, right? If I check, let me draw it right again for you. If I select this person in this carbon chain in this way, here you have the same substituent here, exactly like this. So in this IUPAC naming, so 1, 2, 3, 4, 5. So this is the most preferred method that I can do, right? This is the most preferred way I can do, or else you can do in this way, no harm, right? Now see, you should know what is the name of this substituent, right? You know, once you have CH4, we call this one as methane, right? This ane suffix come because there is an alkane, right? Because there is a completely hydrocarbon case. So there is no double bonds over here because only we have carbon, 1 carbon only. In the case of C2H8, right, you will call this one as ethane, right? Ethane. If you go with this 3, you will say propane, butane, pentane, hexane, heptane, right? No harm, right? No harm. Okay. Now see here. You got CH3 over here. So if I remove 1 hydrogen from each of these people, because if you now this is the structure of methane, right? If I remove 1 of this hydrogen, if I attach to this, then I can get CH3. That's what it has happened here, right? It has been attached to this carbon chain. So if this is attached over here, instead of this, then there is a name given in the IUPAC for these people. So if it is 3x3 dash, which is attached to this, we will use the suffix il, right? YL, il suffix, right? So over here, this has to be methyl. This has to be methyl. In the case of ethane, if you remove one hydrogen, you will get C2H7. C2H7. So you will call this one as right over here. Wait a minute. So you will get here C2H6, or C2H7. Sorry. So C2H5 will be there. So you will say this one as ethyl, right? Ethyl. So you will use this il suffix over here, right? The name will change with the suffix that we use. So in order to name a compound with respect to their functional group, the suffix will show you what kind of functional group is this total compound, right? So that is the important part over here. In the prefix area, keep in mind there will be your substituents, the numbering of the substituents that you have, right? So now let's come to this question now. Now I have marked the lowest number. In this case, I have taken in this direction. You can do it in this direction also. Same number will be there. If you use 1, 2, 3, 4 and 5 over here, you will get in this direction. So same numbering will be there. This is also 2, this is also 2. So as I said, first of all you need to mark the substituent first. So substitute is attached to the second carbon. So therefore, you should first write the number of carbon. At which number of carbon is this methyl attached? So 2 methyl, right? 2 methyl, right? So since this is attached to the second carbon, you have written 2, and it's a must you have to write dash over here, right? It is a must that you have to write dash over here, and here you have to write methyl. Next, you need to write methyl. Next, over here, you don't have any other substituents. No other substituents are there in this case. So over here, just see, you have how many carbons? So 1, 2, 3, 4 and 5. So according to the numbering, you know, if you use 5, if there is 5 carbons in a carbon chain, you have to use pent. So the IUPAC for this is pent, and you have all alkanes, right? So the suffix has to be in. Understood? So at the end of this IUPAC, I will give you the prefix and suffix for their respective functional groups, right? And there is a special note also that you have to know. So the IUPAC for this compound is 2-methyl pentane. Understood? So this is the case for this compound, right? So this is the case for the hydrocarbon, right? This is the case for the hydrocarbon, right? Right. Right. Hope you guys are noting it down. Note down the main points that you got. Right. Note down the main points that you got. Right. Right. Now this is for the alkanes. But if there is a double bond, let's take this example. Let's say now we are having the functional group or the double bond character in this. So this is actually an unsaturated carbon. Same way as we ordered for the alkane over here. So accordingly, you should also show what kind of the numbering system that you have, right? So you need to know what's the numbering system over here, right? So over there you have 4 carbons, so it has to be bute, right? First of all, see the numbering system. Now in this case, right, in this case, you can do the numbering system like this. So 1, 2, 3, 4, or you can do in this manner 1, 2, 3, 4, right? You can do it in this manner. So over here, keep in mind, as I said you, find the longest carbon chain and find whether there is any substituents in your longest carbon chain. In here, you don't have any substituent over here. You just have a straight carbon chain. So you just have an aliphatic carbon chain over here. And here you have a double bond. So obviously this whole system, this whole compound has to be alkenes. Alkene. If the suffix is actually ane, you should know it has to be, everything has to be a carbon-carbon single bond. But in the case of this fellow, keep in mind, here you have a double bond here. So actually it has to be alkene. Right. So if there is no substituents, don't worry. Directly you can go with the compound naming, right? You can go with the numbering of the carbon chain. So here it's 4, right? So it's bute. It cannot be butane. You guys can think in that way, but actually that's wrong. This is alkene, right? So if this particular compound is finishing with alkene, you should know the suffix has to be "-ine". Here, the suffix has to be "-ine". So, in numbering in these areas, we have either in this direction and this direction. See the double bond which has the smallest number of carbon attached to it. If you come from left to right, here you have 1, 2, 3, 4. Here the double bond starts at the 3rd carbon. So according to our IUPAC rule for the organic compounds, we have to consider the one which has the lowest number. So if you go from here to here, this is actually not possible. You can't use this numbering rule from left to right. But in the case of right to left, you have the number 1 carbon which is starting with the double bond, right? So how can we write the IUPAC for this? Now see, so bute, I just directly started because there is not a substituent. Bute 1, because we are starting in first carbon, ene. This has to end as ene. So you just wrote 1 because the double bond just starts at the first carbon. Once you start marking from left to right, so from right to left. So 1 dash, there is nobody over here, just only the double bond, alkene. So ene is here. Now some of you can ask, instead of 1, why can't you neglect them? You can neglect because it's starting with 1, no? So you can directly neglect them. You can write them as bute, right? Wait 1 minute. You can neglect the number 1 in the case of this case, ethene. Over here, you can do one thing. They can ask you an IUPAC that you can bring, that they will write a compound. In this case, let's say 1-butene. So what does this mean? So no harm. It is just written like this. So if you have bute 1-ene, there's another way to write them up. So you can bring this number 1 carbon over here. So you get 1 dash butene, right? Butene. You can write in this way. So if you write in any of these ways, you will get the correct answer over here. Right? Understood? Same case will be applied for the alkyne. So let's do another example. Right? Let's do another example over here. Right? So let's do another example over here. So right over here, just as we considered for the alkene, you can consider this one for alkyne. So in this period, see here, you have 1, 2, 3, 4, 5, 6, 7. 7 carbons. 7 carbon compound is here. But once you are writing the IUPAC, you will be finding the longest carbon chain. Right? That's our rule. As we wrote for the double bonds over here, same rule will be applied over here. Whatever rules we wrote, it will be applied here. But the thing is, here you have alkyne. Here you have alkyne. Since this is alkyne, your suffix has to end in "-ine". Your suffix has to end with "-ine", right? Y in "-ine". So as per the previous ruling, right? 1, 2, 3, 4. You can go like this. 5. No harm, right? Let's see what will happen. So this is one of my longest carbon chain. 1, 2, 3, 4, 5, 6. There is also another longest carbon chain. And here 1, 2, 3, 4. Here also I have another longest carbon chain. But see here, there is a problem. Just as I explained for the alkanes, here also the same, right? See here, you don't have the shortest carbon chain over here. I can directly omit them. Among this numbering system, see who has the longest carbon chain. Here you have 5 in this direction. Here you have 6. Right? So 1, 2, 3, 4, 5, 6. You have 6 carbon. So I just directly know which numbering system will give the lowest number to me. So what did I do is, I just directly took from here. You can check, like if you can do in this pair also, no harm. 3, 4, 5, 6. Right? You can do it in any way, in either ways, right? No harm. So 1, 2, 3, 4, 5, 6. See here 1, 2, 3, 4. Here 4th carbon is only having starting the triple bond over here. So it's not possible now. So directly what I can omit this number. I can omit this numbering pattern. I can do in this manner. See here 1, 2, 3, 4, 5, 6. Here 2 has the triple bond starting. So therefore I can consider in this manner. I can't consider 1 to 5 because this is the shortest carbon chain and I have a longest carbon chain. So I can consider this method now. So what I can omit this one also. Right? How can we name? Same way as we wrote here. What you can do is, here you have 6. So according to our IUPAC nomenclature, for 6 we can use hex. Right? So 6 you can use hex. Right? Keep in mind, you should not forget one more stuff. Over here, before going to the IUPAC, you should mark the substituents that you have. Out of this, you have this fellow. So you should write here methyl. Because 1 carbon now. So for methane, if you remove 1 hydrogen, you get methyl. Right? So this is attached over here. So now, go for the IUPAC naming. So first things first, as I said you have to write the substituent. So this is there in the 1, 2, 3, 4. Fourth carbon. So this is attached to the fourth carbon. So how I can write? 4 dash methyl. And what is the number of carbons that we have? 1, 2, 3, 4, 5, 6. So 6 means hex. 6 means hex. And see here, this compound is completely alkyne. So therefore, it starts with the second carbon. So 2 ine. 2 ine. As I said you, over here, right? Over here, as I wrote for this guy, right? For the butene, I took the number 1 and wrote over here. Same way you can do for this fellow also. No harm. But keep in mind, once you are writing 2 over here, you should know it is indicating for this fellow. Right? Mostly they give you the answers either in the numbering pattern difference, right? So in the numbering patterns it will be different. So you can write like this also. So for methyl, right? Dash 2 hexine, right? Just bring this fellow in front of this hex, right? You can't put in any other place because it will give you wrong information about the compound. So be accurate in it, right? Be careful in this part. So this is for the hexine. So you have 4 methyl 2 hexine, right? 4 methyl 2 hexine. So now we finish the naming part of the hydrocarbons, right? Just a basic part. Whatever rules that we did, whatever rules I said over here will be applied for the hydrocarbons respectively. So take the respective notes for that. So in IUPAC, I will just divide it into two. So hydrocarbons is one part. Hydrocarbons is one part. And the another functional group cases for me the second part. So Alhamdulillah, we finished hydrocarbons just now. IUPAC of hydrocarbons just now. Right. Now over here. Right. So I hope you guys mark down the numbering system over here. Right. Hope you guys did the numbering system over here. Right. So sorry for the inconvenience just now. Just now power cut was there. Right. So this is how we finish for the functional group. So in summary, we finished hydrocarbons very much recently. Right? We finished hydrocarbons very much recently. Now the next one we have is the functional group. Right. Now let's go into the topic right now. In the functional group IUPAC, in naming the functional group of IUPAC, you need to know that there is a subject called priority in the naming a functional group. For example, let's say I am taking this compound over here. Right, now see here. Now I have this kind of fellow. Right, now see here. You don't know what kind of a functional group is this. And you don't know what kind of functional group is this. Right. So now here you have two groups. So for this you will say alcohol. So this is actually alcohol, not hydroxide. In IUPAC of organic chemistry, this is actually an alcohol, not a hydroxide. Keep in mind. So this is alcohol. So this is a functional group. This is alcohol, and the C double bond O in between these two carbons, we say this one is ketone. Ketone. Right? Ketone. So here you have ketone, here you have alcohol. So here you should know there is something called prioritizing the functional group. There is a limit for each of the people, right? So within those limits, the one who is higher than one of the functional group, he will be named as the particular functional group, right? So accordingly, you need to know who is higher. In this case, ketone is going to be higher than alcohol over in this case, right? This is due to the priority table that they have given in your resource book. You should know what kind of priority that we have to give for these people over here, right? So accordingly, note this down, right? Very much note this down. A very important part. If you don't memorize this part, right? If you don't memorize this part, obviously you will lose marks over here in the IUPAC itself. It will come in first 10 MCQs. Keep in mind, again and again I'm saying, you will be losing 1 mark, which is actually a nonsense work, right? Don't do in this way, right? Right. Now see, so here I just said we can consider the ketone group over here. So how? So you should know the priority table. So what I'm going to do is, I'll give you the functional group, right? The functional group, right? The functional group, right? Its suffix. That's the important part, right? Because you are going to name the functional group now. Suffix, and then I'll give you the prefix over here, right? Prefix over here. So accordingly, first things first, you have this group. So this group is called actually carboxylic acid. Note this down. This is carboxylic acid, right? So he is under number 1 priority. He is under number 1 priority. So this suffix at the ending part. Now see here, right? Now see here, in the ending parts, we wrote the particular respective groups that they belong to. Since certain people we don't consider as their functional group, we just finish them with their normal names. So here you have alkenes, so we'll end them up with the "ene." In this suffix case, here you will be mentioning the functional group, right? Here you will be mentioning the functional group with respect to their compounds that we found in this case, right? Now see, now here you have carboxylic acid. In the carboxylic acid case, as the suffix, you have to add oic and you have to give a space and then you write acid. You cannot join and write. There is lots of MCQs where oic acid is being attached to each other. Like they will be like this. They will be in this manner. This is actually wrong. Right? It has to be in this way. Oic, give a space and then write acid. Oic acid. Since this is the highest priority, you can directly omit the prefix. There is no prefix for this. Secondly, you have this fellow, right? Here you have H. Now here you have R. So this group is actually called ester. This group is actually called the ester. So here the suffix is actually O8. O8. This is going to be a suffix over here. Right? Keep in mind, they won't ask you the prefix for this fellow because these two are carboxylic acid derivatives. That is actually not there in your syllabus, right? So for naming this one, there is a different work to do. In other case also you have different work to do, right? Now see, right? Now see here. Here you have, right? The groups that we have, right? Here you have the groups. Now see, for the second one, we took ester. So O8, right? Exactly O8. Now for the third one, you have C double bond X. You have used this term X in most of the cases, right? In most of the cases, you have used X. So X in a sense, keep in mind, right? X means halides. Yeah, use this one in organic chemistry. Halides. So in the case of halides, it can be fluoro, chloro, bromo, or iodine. Right? It can be any of these people. But mostly you will get the chlorine one. Right? You will get with the chlorine one, not with these people, right? Most of the MCQs that you got is actually with this. So this one's name is actually acid halide, right? Acid halide. So if in the place of X, if there was chlorine, you will say acid chloride. If in the place of X, if there was F, you will say acid fluoride. If in the case of X, if there was bromine, then you will say acid bromide. The same way it will be for iodine also. That it will be acid halide. Understood? It will be acid halide. So the suffix, the functional group, if this one is dominant, you will write oil halide. Oil halide. Right? Oil halide. Okay, so keep in mind the prefixes and suffixes for the respective people that you have, right? And in the case of prefixes, right, in the case of prefixes, here also you don't need to worry, they won't ask you. You haven't got such questions in the syllabus, right? So prefixes not there in your syllabus for these people if they can't give you such kind of compounds. So fourth one, you have C double one O NH2, right? C double one O NH2. So this fellow, with respect to this, I mean, you say this one as amide. This one is actually amide. So in this case, you don't have a prefix. The prefix is actually not there. But in the case of functional group naming, right, which is suffix, it will be named as amides. It will be named as amides, right? It will be named as amides. So you need to know what is the priority, right? You need to know what is the priority over here. Now, in the fifth one, right, you have CN. This is not cyano. The name of this fellow, according to organic chemistry, we say this one as nitrile. Nitrile, right? Nitrile or nitrite, whatever it is, right? Nitrile, right? And in the case of prefix, here you know, in our organic chemistry, we use CN called as cyanide, right? We use CN as cyanide. So CN, cyano, right? We'll say this one as cyano. In the case of suffix, see here what compound we use? Nitrile. See here amide. So in suffix you kept amide. Here nitrile. Here also it has to be nitrile, right? It has to be nitrile. Nitrile, right? Nitrile, right? Let me divide this portion also. Right? So this is the fifth one. Now your sixth one is this. So in sixth one, you have C double bond H, or they'll give you in the exam like this CHO, right? So I want you to put a star point for this because this is a very important case. During the numbering case, the IUPAC can change, right? The IUPAC can change, right? This C double bond CH. We call this fellow as aldehyde, right? Aldehyde. So in the suffix area, if this one is a functional group, we will use al suffix, right? In the case of prefix, if this aldehyde came with the carbon chain, right, with carbon skeleton, let's say carbon skeleton, right, with carbon skeleton or chain, with carbon skeleton or chain, the name will be oxo, right? The name will be given as oxo. I'll explain you how in this case, right? I'll give you in the name oxo. If it is without means, let's say if this one came as a substituent completely, right? Without the carbon skeleton, it just came without the carbon skeleton or chain, you will use the suffix formyl. You remember the word formyl? that is used in the mortuary, right? So formyl. So that is the suffix cases and prefix case for this group. So this is called aldehyde. Now the seventh one, this one is actually this group that you know. So whom did I explain? I explain you this guy. So who is he? He is actually what I said just now. He is a ketone. He is a ketone. Since if this one comes as a suffix, right, which is a functional group, we will use this one as own, right? We will use this one as own. Once you get this one as a substituent, right? Let's say if this one is in the functional group, let's say if alcohol was the functional group, here this one becomes a substituent, right? Here it becomes the substituent. If this one comes as a substituent, keep in mind, here you have an oxygen. So as a result, what name that we used for this fellow will also be named here. So this one is also oxo. Oxo means oxygen, right? Oxo means oxygen, right? Right? Oxo means oxygen. So actually, this is a case for ketone. But in this case, aldehyde, there is two cases that they haven't mentioned in the resource book that I'll explain you by doing certain questions which has come through the past paper. Now the eighth one that you have is actually the OH group that I have explained you just now, right? Just a few minutes ago. So this one is actually the alcohol. Alcohol. If this one becomes a functional group, you have to finish this one as ol. Ol. If this one comes as a prefix, right? If this one comes as a prefix, let's say if it is substituent, see here you have this one as a substituent. In this case, see here, there's a thing that you should know. You know that OH is actually hydroxide, right? According to the inorganic chemistry, right? Inorganic chemistry, we say OH as hydroxy. So here, the prefix is going to be hydroxy, right? It's going to be hydroxy. This is going to be hydroxy. Understood? So this is going to be your naming for prefix of these people over here, right? 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 So I will give you a break around 10 o'clock. So another 1 hour more. So we'll try to finish the IUPAC part. So we have a huge part which is the reaction part, right? We have the isomerism, then we have the reaction part. So we'll finish this one quickly. We have another 1 hour more. And finally you have the NH2 group. So you know this one's name is going to be amine, right? This is going to be amine. If it comes for the suffix, right, we will use this one as their name respectively. So this is also going to be amine. But in the case of prefix, you will use amino, right? In the case of this, you will use amino. Just only one letter has been changed, right? One letter has been changed, that's all, right? If it is suffix, if this one becomes a functional group, right? If this one becomes a functional group, keep in mind, you will use amine. If it is prefix, you will use amino. So that is going to be your 9th one. Now for 10th one, right? And others and all, you need to know just by the prefixes only, right? There's no suffix, right? 10, 11, 12. There's no anybody here, right? Like that. So 12, 13. So here fluorine, chlorine, bromine, iodine, and finally you have NO2, right? If they attach to the carbon skeleton. So they don't have any suffixes, right? They don't have any suffixes over here. Instead, they have only prefix. So you will use this one as fluoro, right? Chloro, bromo, iodo, and then you have nitro, right? You say this one as nitro. We say this one as nitro. So this is the complete area that you should know, and you have to keep this one within your mind. So this is actually a very important part over here, right? Understood now, right? Now see here. Now see here. Now here you have all these people, right? Here you have all these people. Now let's do the IUPAC naming for this. As usual, what you have to do is find out who is the prioritized one. Here one new thing is there. You should find who is the functional group for this compound. For this compound you have two groups here. One is alcohol and ketone. So according to priority order that you have seen, see here you have alcohol over here, and here you have the ketone. So who is having the higher priority? Than alcohol you have ketone. Ketone is the under highest priority. So this whole compound is actually belongs to ketone, not to hydroxy. You cannot even say a part of this is going to be alcohol, a part of this is going to be ketone. That's actually wrong. If you are naming the functional group, you should understand that the whole compound belongs to that particular functional group. So here you have ketone. So ketone is the dominant one. So by naming the carbon, see here. So you should find out which carbon number that you have to use. If I go through this way, it will be longer. See here, 1, 2, 3, 4, 5, 6. If I use this also the same, 1, 2, 3, 4, 5, 6. Really impossible, right? You can't use the longest number carbon for this IUPAC. So you should use a short one. So only one way is either this or this way. So 1, 2, 3, 4, 5, 6. Right? Now see here, we took this carbon chain. We took this carbon chain. So this is alcohol, no? This is alcohol, right? So now this one has become your substituent. But keep in mind, you should not forget, there is one more thing that you have to consider. That is also this fellow. So this fellow is actually methyl, right? For this OH group, we are going to use the suffix over here, prefix over here. Who is it? It is hydroxy. It is actually hydroxy. Understood? So hydroxy. Now first things first, as I said, first thing you have to consider the prefixes, then about the number of carbons that you have, and then your suffixes respectively. Right? Now see. So in prefixes you have hydroxy and methyl. Now you need to know what is happening to this case. In this case you have two people over here with different categories, right? So in order to name these two, there is a rule in IUPAC that you have to name the substituents. Name the substituents with respect to their alphabetical order. So which indirectly means from A to Z order, right? Alphabetical order means from A to Z order. So over here you have prefixes over here, right? So I have written the prefix here. For OH we have hydroxy. In the case of CH3 we have methyl. Right? In the case of CH3 we have methyl. Now let's name this up. Both these people attached to the same carbon. No harm. So which letter comes first in the alphabetical order? H, right? So 5 hydroxy, give a dash again. You must put dash. Without putting dash, you can't do. You can't write the UPS. It's actually wrong. So there's a rule. You have to give gaps here. So a numbering will show at which carbon is this particular hydroxide group is at OH group is attached to the carbon skeleton. Since over here, see, you cannot ask me why didn't you consider this one as the total functional group. Why? Here actually we have ketone. Understood? So 5 hydroxy. And second thing, you have methyl. At which carbon? 5th carbon. So 5 methyl. 5 methyl. Now next thing, all the prefixes are over. Don't consider this one as oxo. This is actually ketone. So you have to consider the whole thing here, as I have explained you here. So methyl. Now go for carbon number. Already have marked. It's actually 6. So hex. Still not over. You cannot use hexane because it is on ketone. See the location of the ketone. At which carbon does it start? 1, 2, 3. At the 3rd carbon. So hex 3 dash. Now you should write what kind of functional group is this. Now this is the suffix of ketone. So you should use on. So hex 3 on. Right? So this is actually on. So the IUPAC is actually going to be 5 hydroxy, 5 methyl, hex 3 on. I can write this in another manner by bringing this 3 in front of hex. So 5 hydroxy, 5 methyl dash 3 hexone. Do you understand? You can write this in this manner also. This is also correct. This is also correct. This is also going to be exactly the same. Right? So 5 hydroxy, 5 methyl, 3 hexone is also correct. 5 hydroxy, 5 methyl, hex 3 on is also correct. Understood? So that is the thing that you have to consider in this case. Right? So another 45 minutes left. Now there's one more part that you need to know. Right? There's one more part that you need to know. So we'll finish that up. Finally, we will do some past paper MCQs also. Right? Right. Now see. Now let's go one step more deeper. Right? Let's go one step more deeper. So guys, take out your Pesuru books. Pesuru. So I'll show you one kind of MCQ that has come in the previous year. So take 27th MCQ of a Pesuru book. 27th MCQ, 2020 5th MCQ, right? Year 2020 5th MCQ. Fifth MCQ. right? Right? Over here. So they have given you a compound like this. HOCH2 CH CH3 C double bond O CH double bond CH bromine. Now they are asking the IUPAC nomenclature of this compound. Now see here. Here you have just a straight carbon chain. You can go ahead and say this way. Now here consider what kind of functional group that you need to have. Here you have bromine. You can consider it as the functional group. Here you have hydroxy. Here you have ketone. So actually the functional group for this compound is actually going to be ketone. By the priority wise, aldehyde is the highest. Right? Aldehyde is the highest. Sorry, not aldehyde, ketone is the highest, right? So you have to start naming the numbering, right? So 1, 2, 3, 4, 5. So I went from left to right. And now 1, 2, 3, 4, 5. I didn't consider this numbering because you don't know how to name this one. That is not actually not there, right? There is no such thing called CH2OH group in the IUPAC naming. So consider the longest carbon chain. So see here, there is one more rule. The thing that you are going to consider, the carbon skeleton that you are going to consider, in this particular cases, you must know that there must be double bonds, all the substituents that you have, and also the type of functional group that you select, right? The type of functional group that you select. So here you have the ketone, hydroxy, CH3, and you should also consider the double bond and also the triple bond nature, right? You have to consider also the double bond and the triple bond nature. Also the double bond and the triple bond nature. So very easy one. But by naming, you need to have certain idea. Okay. Right. Here there is going to be a small rule here, right? So in the suffixes, right? Here you have double bond. Now you will get a problem. Here you will have in. At the same time you will have on. So you will have a doubt. Do I need to write everything in the suffix? Yes, you have to write. But what you have to do is, first things first, you have to write what kind of hydrocarbon is this. Hydrocarbon means this is actually not hydrocarbon. What is there in the carbon chain? Is it double bond or triple bond? If there is triple bond, it will be like this, right? If it is triple bond, if this one was triple bond, this has to be in and on. But now on this question, they have given you this in and on, right? So the functional group has to be in the last. Obviously, it has to be the last. No matter what happens, it has to be in the last. Before the in between the numbering of the carbon and the functional group, this double bond or triple bond has to be mentioned. So there's a rule in the IUPAC. If this kind of cases happen, here you have to omit the E at the end, not this E. Omit the E which is there in this end. Okay. So it will be like in on, right? It will be like in on. Now, according to IUPAC numbering, see here you went from left to right 1, 2, 3, 4, 5. Then right to left 1, 2, 3, 4, 5. Same number has come for the carbon 3. So ketone. So his carbon number is actually hasn't changed. But see here you have the carbon number changed. Understood? So here you have to give the priority. Okay. So first things first. So the rule is, first thing you need to know what is the functional group, right? You need to know what is the functional group that is there in that particular compound. Second thing, you have to know what all the substituents are there. At the same time, is there any double bond or triple bond in that nature? Right? That is the second priority. So if there is double bond or triple bond, how long or how short it is, you have to consider. It is a must for you to consider in this case. Understood? You have to consider. Third thing, if all of these aren't there, you have to consider who is having the longest carbon chain. So accordingly, the IUPAC nomenclature that we did for the hydrocarbons will be under the third category, because there is no any functional group now, right? I'll give you a note after this that what is the case over there, right? So over here, see, here you have on. So here you have to consider double bond also, and if there is triple bond also, you have to consider triple bond. But keep in mind, in your syllabus, they will ask only one double bond or one triple bond. They will ask you two. Understood? They will ask you two. So now see. So 1, 2, 3, 4, 5. So I have took this numbering system, then this numbering system. This is easy, right? Because I need to consider the carbon which is having the less number. Right here, the less number is for this fellow. Right? Now see, in the IUPAC, right? In the IUPAC, right, now we'll name. So first of all, you need to know who is the prefixes here. So here you have three prefixes. One is methyl. Another one is hydroxy. Another one is bromo. Right? Hydroxy bromo. As I said, you should consider their alphabetical order. You need to show their alphabetical order. So that's a must. So according to the alphabetical order, you have B, H and M. Right? So first things first. So he will be named as 1 bromo, because we named that carbon as 1 bromo. Next one is this. So 5 hydroxy dash. Here you have the fourth carbon. 4 methyl. Now check the numbers of carbon that you have in this skeleton. So 5 means pent, right? Pent dash. As I said, now you have to consider this fellow, ene. Ene is coming with position here. 1 ene. Remove that E. Dash. At what position you have ketone? 3, right? 3 on. Right? Now check the answers. Right? So what is the answer? 1 bromo, 5 hydroxy, 4 methyl, pent, dash 1, dash N, dash 3, dash on. So this is actually the third answer. So this is going to be a third answer. Got it? Did you get it clear? Right? So this is the case. Next, so this is the case for the IUPAC over here. Right? For the IUPAC. Understood? So consider whatever rules that I have mentioned you, right? You must consider whatever rules that I have mentioned you, and take the notes in time, right? Complete the notes and let this one be a revision for you all, right? Let this one be a revision for you all. So we finished the IUPAC nomenclature of functional group and hydrocarbons. So completely our IUPAC nomenclature is getting wind up right now, right? It's completely wind up. Now we have finished it completely. Now let's go with some past paper MCQs, right? Let's go with some past paper MCQs. Now your task is, right? Now your task is to go home, take your resource book, because for chemistry, out of the resource book, nothing will come. If something that comes out of the resource book will be given all marks. There is no doubt in it. So you can go to the page number 17, right? Page number 17, there you have the priority, right? At the same time, you have to go to page number 20, there they have given the rules, right? There they have given the rules. Understood? Now they have given the rules. Okay. So now let's dive into the past paper MCQs. So go to page 0, right? Now take 1983 8 MCQ, right? 1983 8 MCQ. So first question, 1983 8 MCQ. So you have CH3, C double bond, CH2, 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 C double bond CH3, right? The IUPAC name of this compound is, so as I said you, what is a functional group over here? You have ketone. So you need to mark the functional group that has the lowest number, right? If it is same number only, what you have to do? You have to consider the double bond stuff, right? But in this case, here we have the carbons over here, but the problem is the ketone is being so less. If you mark from here, right, the numbering of this will be very less. So you have to go in this manner, right? No harm. If this one comes in the middle of something, like let's say if there was 5 carbon and if it was in the third position, then you have to consider the numbering part of the double bonds, right? So now see here, now this is ketone, right? So mark for 1, 2, 3, 4, 5, 6. And now here you have another functional group, another substitute, right? You have a substitute here. So this is methyl. The name is methyl. So functional group has to end in on. As per the previous question, right? You write the IUPAC nomenclature. Now you have a prefix here. So write the substituent. Which carbon it is? So fifth carbon. 5-methyl. 5-methyl. Now is there any substituent? No. Go with the number of carbons. So 6 means hex dash. Which carbon is the starting of double bonds? So in the fifth carbon. So 5 in dash, because there's another subfunctional group. So here you have ketone. Ketone is in second carbon. Dash 2 on. So see here. So here there is a small error, right? In the question itself, there is a small error. There INE is being used according to their old syllabus, right? 1983 they have used E there, and actually lots of mistakes are there in page through, right? Keep in mind, lots of mistakes are in page through. So actually here third one is the answer, but if you bring this 5 in front, right? Keep in mind, just whatever rules I said, just use them. Methyl 5 dash hex in, right? Hex in 2 on. So this is the IUPAC nomenclature. So the answer is actually third one, right? Third one is the answer. Understood? Third one is the answer. There's lots of spelling mistakes here, right? In the past paper. Now let's go to the second question. Let's go to the second question. So CH3, CH double bond, CH, CH, CH3, CH, CH3, CH2, OH, right? Now what is IUPAC nomenclature for this? Over here you have the functional group here. So as I said, you need to consider the functional group as well as the double bond nature in this compound, right? So here you have 1, 2, 3, 4, 5. So out of this you have one substituent who is it is just methyl. It is methyl. Now start naming. So second carbon 2 methyl dash. Now here you have the carbon, right? Now there is no any other substituent. Here you just find how many carbons are there. So 5. Sorry, right? Pent, right? Pent. Just as we wrote for this one, here you have in and then you have ol. Remove the in, so we'll get in ol, right? So pent dash, it starts by the third carbon, so 3 in dash 1 ol. So what's the answer? So this is 1984 78th MCQ, right? So 2 methyl pent 3 in ol, right? So second answer, they haven't put the one right there, right? Because it's already first carbon now, so they have neglected. So you can write it in this way also: 2 methyl pent 3 dash in ol. You can write in this way also, right? In ol. There's not a dash. You can write in this way also and this way also. This is also correct. So the answer is the second one. Second one is your answer, right? Now let's do the final part, right? Let's do one question. You can directly omit the 1994, right? Keep in mind 1994 MCQ, mark them up, send in MCQ. Right. So this is actually out of syllabus because you don't have the IUPAC naming for such compounds, right? Now this changed actually. So I'll try to wind up the session, right, for the IUPAC now. We'll do one more question. So we will do the complex one, right? You feel like the complex one, but actually no. So I'll do the fourth MCQ, which is 1993 10th MCQ, right? Let's jog into the question. So CH3, CH2, CCl, double bond, CH2, CH2, CH3, CH2 CH Br C double bond OH. C double bond OH. Right? So here, according to priority, carboxylic acid is going to be in the first place. And see here, you need to consider double carbon also, double bond also, not double carbon, double bond also. So the IUPAC will be like 1, 2, 3, 4, 5, 6, 7. So your substituents are going to be this and this and this. So you will say this one as chloro. Your prefix is going to be chloro. For bromine, you have bromo, right? And this is going to be propyl. Meth, eth, prop, third carbon, propyl. Keep in mind one more thing. The IUPAC has to be written everything in simple letters, right? Not in the capital. You can't use a single letter with capital, right? Everything will be mistake. So see here, what all I have written is actually in small letters, right? IUPAC has to be written in the simple letters. That's an important thing you have to know. So now start to write the prefixes according to their alphabetical order. So B, C, P. So first thing is bromo. So I'll write the answer over here. 2 bromo. Then you have 5 chloro. And then you have 4 propyl, right? Propyl, right? Propyl. Now there is already substituent. Now go directly to the number of carbons. Here carboxylic acid's carbon also I have to mention. That's an important thing. So here the carboxylic acid has a carbon. So I have to mention that one as number 1 because he is in the highest priority. So 1, 2, 3, 4, 5, 6, 7. So 7 means hept dash as usual in oic acid. There has to be space in oic acid in these people also. So the double bond starts at the 4th carbon. So 4 dash in, instead of 1 I can just directly write oic acid. So 2 bromo, 5 chloro, 4 propyl, hept, right? So see here hept 4 enoic acid. You can write this one in other words, in other way also, like this. So 2 bromo, 5 chloro, 4 propyl, hept, right? You can write, bring the 4 in front, right? You can bring this 4 in front of heptene. So 4 hept enoic, heptenoic acid, heptenoic acid. So see the answer. 2 bromo, 5 chloro, 4 propyl, 4 heptenoic acid. Or see here, most of you have been under pressure, right? Usually you will mark the first answer because see it's exactly nearby. But see there is a small change. Instead of PT, they have used hex. So 6 carbon. Here actually 7 carbon, right? Numbering has to be very much careful. The compound can change. So 1, 2, 3, 4, 5, 6, 7. Right? 2, 3, 4, 5, 6, 7. So 7. So hept. So it cannot be 5th carbon. So 4th carbon starts with double bond. Right? So your correct answer is the second one. So second one is your correct answer. So finally we have completed the IUPAC nomenclature. So now the time is now 9:40. We will take a 20 minutes break and we'll start the next session in 20 minutes inshallah, right? So by the way, Assalamu alaikum wa rahmatullahi wa barakatuhu.